I'm Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. And we are here at Tech Field Day for a discussion of CXL technology. By way of background, Compute Express Link, or CXL, is a new technology that allows you, system architects, system engineers, designers to extend almost any system resource across PCI Express. This is obviously happening already for things like storage, which has been embracing and adopting NVMe, which is PCI Express attachment, for a while. It's, of course, also the typical way of attaching GPUs to a server. But very, very soon, and increasingly, PCI Express is being used to attach a lot of other things, including CPUs, memory, XPUs. And then that's sort of running into another interesting trend, which is extending PCI Express outside the box with switches and fabric technology. And if you put these things together, Compute Express Link promises to allow a really new type of system architecture. So instead of having the CPU and the memory and the peripherals and the I/O and the storage and everything tightly coupled in a box, CXL would allow you to have a loosely coupled system with a variety of different peripherals and specifically a right-sized system. So we've been talking about this on the Utilizing Tech podcast series that we've been running for the last 6 months here. Craig, who is one of our delegates here at Tech Field Day, along with Nathan Bennett and myself, we've been interviewing people in the industry. We've talked to people from Intel and AMD and ARM, as well as most of the software and memory and switching people, and asking them the question, how is this practical? What is this going to do to enterprise technology? And I think we've learned quite a lot. But today at Tech Field Day, we're going to be hearing from some of those companies that are developing products in CXL. We're also going to hear from the CXL consortium itself. And I thought that as a lead into that, it would be good to sort of pose the question to our delegate panel, asking, I guess, first, what do you know of CXL? What do you see this technology bringing to your specific area? And what are you excited about with CXL? And just to introduce what's going on here, this field day session, as all of our field day sessions, we have a dozen delegates from a variety of backgrounds. So we have people here who've specialized in storage or networking or servers or cloud or orchestration. And many of them don't have as much understanding of other parts of IT and may not even know a lot about CXL. But I think that the goal of all of our work as part of Gestalt IT is to have conversations with technical people who are interested and curious and want to learn more. And that's what we're going to do here today. So in order to kick this off, I would love to actually call on my co-host for the Utilizing CXL podcast, Craig Rodgers. Now, Craig and I, as I said, have been having this conversation. I wonder, Craig, if you can give us sort of a reality and vision statement. So sort of where are we with CXL today, and where is this technology hopefully going in the future?
Okay, where we are today is we have added a new layer of functionality to the PCI Express slots that everybody's familiar with, most likely. And now that we have the later generations of CPUs from AMD and Intel and ARM, and I'm sure others, we actually have platforms capable of leveraging CXL to perform tasks. Right now, that's mainly focused on memory expansion. And over the very short-term, near-term future, you're going to be hearing a lot around memory expansion. That'll evolve into pooling and then composable racks, trays of CPUs, GPUs, etc., RAM. And that's pretty much where we are now. To 5 years down the line, I would expect 5, maybe 6 years down the line, we would be looking at composing racks as opposed to servers. That's exciting.
And the use case right now, whether it's RAM or whether it's composability, is to basically have a server that is fit for purpose. And I think that that's the most important takeaway from all of the conversations we've had. The idea is that instead of building a server based on sort of what the system can or what the platform needs, building it based on what the application needs. So, for example, right now, you can build a server with 1, 2, 4, or 8 CPU sockets. You can build a server with 8 or 12 channels of memory. You basically have to fill the memory channels, and you can only buy memory in certain sizes. And so basically, there really are only a few different configurations of servers that you can build when it comes to CPUs and memory. But in the future, it is very likely that you'll be able to build a system that has pretty much the exact configuration of CPUs and memory that you want. I mean, imagine a system, imagine if your application needed 13 cores and, I don't know, 53 gigabytes of memory, right? Well, you could build that system with CXL, and you cannot build that system currently. And I think that that's the goal. And that's one of the reasons that we're starting to see it right now as it is because a lot of especially the hyperscalers who buy a lot of systems want to make sure that they don't have to buy like the next step up of RAM in order to get just a little more RAM. And instead they can deploy a CXL expansion card. So those of you, whether you know about CXL or not, what is your reaction to this as a architectural solution?
So does this make old technology newer again, or is this? Can I update? Can I take something from 5 years ago and update it because CXL, or is this something that?
I think one important thing is that the CPU has to support it, and so you cannot like update an old server with the new technology. But I think once the CPU supports it, I think there's a goal of having broad compatibility.
We are a Cisco UCS shop with a lot of blades, and we had a discussion with them about the new M7 blades that already support some CXI, and but a lot of components had to change to make it all compatible. So we had to get new chassis. That means also new fabric interconnects. That also meant new I/O modules, and so for us, with still a lot of old hardware, that was not feasible. And I'm wondering what Steven said about just enough memory. I'm not sure if CXI will be or PCI Express will be able to split a memory module. I can imagine that you can assign the number of memory modules, but I'm not sure if you would even go that granular and split even a memory module per gigabyte.
In the current incarnation of CXL 1.1, the memory expansion module will get either presented as transparent system RAM or as a device within, say, Linux that you can load independent drivers on. Come the next generation of servers, you will be able to split out that memory on a I think it's down to block address level. It's not really splitting up the DIMM between servers. It's saying this range of memory blocks is allocated to this server as a device. So you will be able to do that within a couple of years, but that won't be part of the M7 blade functionality. It is a big uplift. Fabric interconnects, new chassis. We've had a lot of blades out of pretty long-term chassis in terms of UCS infrastructure. So the level of functionality you're talking would be more forward-thinking. That being said, the CXL consortium is a group of companies, a couple of hundred, that have all defined the standard. And whilst we've only got CXL 1.1 hardware now, with say Intel and AMD, 2.0 is already decided, 3.0 is already decided, so that's already roadmapped ahead. So we know we've a very good idea of where CXL is going. We'll maybe have to pivot on real world adoption I don't know, but Allyson might be able to add in there.
Yeah, so I think that it's an interesting thing that you're bringing up, Craig, because I think that there's going to be this transition period where you've got legacy hardware and you've got new greenfield hardware, and you're able to do different things with your infrastructure with that new greenfield. I'm most excited for what happens when we get to CXL 2.0, which is the next generation of technology. That's where you're going to start seeing things like disaggregation of systems and some really cool infrastructure that has never been delivered before. And you can imagine, to the UCS reference, more blades of memory. Blades of memory, blades of compute, and the ability for an orchestrator to choose which resources they want to tap for a particular workload. That's really the end game for CXL. I think that's why it was created. And, when you think about the slowing of Moore's law, it's an inevitability that we have to do something like that. So that we can dial in better the core capabilities that any application or service requires. But it's out in the wild right now in 1.1. That we can certainly see some designs coming from the memory manufacturers for some interesting technology in the 1.1 space. I see that as just like dipping the toe, to be honest with you. Some cool designs. You can see where the industry is thinking. But I think CXL is going to bring out some innovation in data center infrastructure that we haven't seen in like 20 years. I think it's really exciting.
Be allocated dynamically, or is that server boot up and that's the memory it gets? Or
They're absolutely talking about dynamic memory, yes.
Mm-hmm.
Yeah, okay. Because that would save us a lot of time in constantly planning where to put the SQL server because of licensing, bigger blades, smaller blades. That would make quite a lot of difference.
One of the first things that I heard that really helped translate it for me was, if you think about it, back whenever we had physical servers and RAID arrays, you had a server with a huge amount of wasted storage, but it was only available to that server. If we skip forward to say CXL2, VMware are already working on this. Say you have a server that's completely network bound or CPU bound, and it doesn't need to have that extra 700 and something gig of wasted RAM, that could be put to use elsewhere. And that's one of the real prime drivers and motivators here. There was another one as well in a previous Tech Field Day event. Nico, you made a fantastic reference to the end game here is, if you think about stretching up a blade center up to rack level.
Mm-hmm.
I don't You did. No, but just your concept of understanding it is, don't think of an 8U blade center, think of a 48U rack, and having that level, that same type of composability around what you're doing with varying pools of shared resources.
I think I did. That was with Memverge, right?
Yep.
Mm-hmm.
Yeah, that comes back to mind. But so my question is, what can we do with it right now? Like, if I want to go out there, what can I do with the new technology? What's available right now?
Well, I will say available right now is EPYC and Xeon 4th generation CPUs and memory expansion cards from Samsung and SK Hynix that you can plug in and run internally within the box.
Okay.
And there are other memory expansion solutions coming very, very soon that will have basically DIMMs on a PCIe card that goes in the server and allows you to basically expand memory that way. That's what's here, 2023 first quarter.
Composable infrastructure has been around for a while. HPE, Dell, and others have been talking about it. The big thing CXL is going to have to get past is all the skepticism of, okay, is this more than just a buzzword? Is this actually going to be something that your average IT shop at a bigger than mom and pop level can implement and make use of?
Well, it would have to be bigger than the mom and pop level, because there's no point in going to this much resource otherwise. What this sounds like to me is that it's a way to give yourself a bigger unit of compute that can be virtualized. The idea that you, rather than having individual servers that you have virtualization running on and you spread the load across it, you can actually turn a rack into a virtualization unit, and you can run maybe thousands of VMs on it and divvy up the memory that way. And I see this as a way of going beyond the idea that virtualization is a server-based resource, that you have servers that have memory and storage attached to them. Now you've actually gone to the point where you can have massive amounts of any resource in one big pool, or one big unit, rather than being a pool of resources.
But particularly
I think
towards
that's correct.
memory, is there any concern about increased latency by putting it on the PCI Express bus rather than being more tightly coupled to the CPU?
Yeah, that's a real smart question. And that is exactly the question when it comes to memory. And the answer, astonishingly, is that we actually have product now that works. And the latency is actually much, much less than you would think it is. In fact, using existing products that you can buy and deploy today, the latency, what we're hearing, what Craig and I heard from companies that have actually tried this, the latency of CXL-based memory is no worse than the latency of accessing memory attached to a different NUMA core in a large CPU.
For the past,
which is amazing, mind-blowing.
For the past 10 years at least, maybe even longer, memory bus speed has not been the limiting factor in compute resources. It's been I/O speed of both storage and networking. Memory bus speed has always been way ahead of any of the other speeds that you actually need in a compute center.
What would be interesting to see, has it been tested with memory-only databases? Because this is where it really stresses, and any latency will come to surface there.
Yeah, and I would ask these companies, in fact, so this afternoon we're going to hear from Memverge and some other companies about that, and that would be a great question for them. The answer is yes, but I would love to see the numbers for that. Another thing that we're hearing on utilizing CXL, which again is kind of mind-bending, is that there are applications that need more memory bandwidth than even 8 or 12 channels of DDR5 can give you. And that's actually another, because I was thinking in terms of memory capacity. Like, you want to make sure you have enough memory capacity. We're hearing that that people are already looking at this, hyperscalers especially are looking at this as a way to deploy more memory bandwidth and basically exceed the number of memory channels that the CPUs support, which again is incredible, but true.
I can see a lot of potential for it for high throughput computing, where you don't need a lot of CPU, but you need to be able to move data really fast in and out of the CPU, which current designs are really limited on.
And then another thing we're hearing as well is there's, in the later versions of CXL, CXL3, I think this is really where this starts to come in, where there's more of a many-to-many architecture in terms of memory access and memory sharing and direct memory access across a fabric from system to system. And so you could see a situation where CPUs, but also GPUs and DPUs and other processors in a fabric are actually directly accessing the same memory regions and sharing the same memory regions for different workloads.
That's coming with 3, so, because I think that would be amazing, the things you could do with virtualization, right? If I have like my storage pool right now and it's just like another storage pool, except it's memory. That would be pretty cool.
Could you say that this is almost like, just bring it back down to earth for someone who doesn't really understand it, making a kind of on-premise cloud more of a reality? Because, when you think of the cloud as a consumer, it's like, well, I mean, there's separate servers there, but to you, it's just a big cloud. You ask, you get, but you pay. So in a way, especially the memory, is that kind of the same thing that's going to happen here? Because as I understand it, you'll be able to share this across. The other thing I want to say too is I can see this as a more I don't say conservationist, but in a sense, because you're not wasting as much, right? The only thing that would worry me though is, as if I understand correctly, you're sharing this. So what about security? Because it's now being spread out. So how does it, how do you don't get someone who's going to intercept and sniff whatever you can do?
Well, yeah, especially if you take it outside the server.
Well, that's
right?
it. It's kind of a service mesh, as I understand it, right? So.
Well, and that's a big concern as well. And that's one of the things that we talked about with many of these companies is, you have to think about authentication, authorization, encryption, access control, sharing, permissions, revoking permissions, so many things that you never had to think about before.
Which add overhead, right?
And do they have an answer? Because in terms of Spectre, right, we're still dealing with the not being able to isolate hypervisors correctly on the CPU level. So now we're taking this to a whole next step with more complexity. And I would imagine it's going to be hopefully not a surprise where we all decide we have to turn off hyper-threading because it's all of a sudden insecure. But I see definitely potential that it could hinder the development of this.
Yeah, I had some of the same questions. One of the things that has plagued the computing industry forever is people getting hung up on the concepts of buses versus networks. And when you try to make a network perform like a bus, you run into problems every time. And this is, if you're actually going to try to make a PCI bus act like a network, it's not a simple problem. It's not a problem that Fibre Channel ever solved. Fibre Channel still sucks at networking to this day because they tried to be a bus rather than a network. I was talking to anybody who remembers DSSD about 9 years ago, and they were attempting to tackle this problem back then. And buses are not malleable into networks very easily at all.
Stephen has a great example that he's used here in this. I honestly think that with CXL, they're trying to extend the bus, not do it over networking. And Stephen, was the Apple connection that is literally Thunderbolt is literally PCI Express coming out of the computer into a device,
Right.
and so I think it's going to mitigate that. Now, obviously, there's going to be CXL switches in version 2 and beyond that will have to switch, but they're doing so with way more lanes. I think most people we spoke to are on 128 or 256 concurrent PCI Express lanes in their existing FPGA CXL2 devices, that have this in play. But coming back to CXL1, the current use cases here are for large amounts of RAM, and indeed additional bandwidth, given it gives two sources. Once you've all mentioned virtualization, we're all comfortable there. To get to where we want to be, there's going to have to be a new orchestration layer, like DRS, the way it sees that a machine is overloaded and migrates a VM. Something's going to have to see that server doesn't need that amount of RAM and reallocate it somewhere better. And those orchestration layers that we need right now don't exist.
Craig, from someone that completely doesn't know this subject, this sounds like this could lead to the complete architecture of servers and changing in the future with the maturity, and could potentially the building blocks look like servers but be sharing the resource that they've got inside them wherever that may be needed. So you might plug in your DL 380 Gen 100 or whatever it would be, but effectively you're then aggregating it across the resources in a rack or a data center to meet your needs? Or is it likely to be separate building blocks and it's bringing those together?
If you look at who's in the CXL consortium today, you'll see that all of the hyperscalers are on the board. And I think that they're looking at it from a standpoint of really disaggregation of their infrastructure and building some custom hardware that will serve their needs. I think all of the conversation in this discussion points to the fact that for enterprise, they're going to need stepping stones to that. If you're in a UCS architecture, for example, you can't just leap ahead into something else. You're going to need some bridging to make the value of this technology come alive for you. And I think that, this is the processor interconnect for Sapphire and for Genoa. So, this is the technology. So it's not like we're going to see processors coming out that aren't using this technology. There needs to be multiple paths to how that instantiates an infrastructure.
There's also another aspect where right now we need to prove the technology. We also need to give software houses time to actually leverage it. There's no point in having, it's like going from single core to dual core. It was no good if everything was single threaded. You weren't seeing any performance benefits. So we need applications to be able to take advantage of this as well. And that'll be an incremental iterative process.
Well, that's again where virtualization comes in, Andy. There weren't any real needs for like 4 or 8 core processors until virtualization came along and said, hey, we can actually run a bunch of different applications on something that has this many cores. I mean, I was working at Sun when they were working on 64 core Spark machines, and like that was great, but there were absolutely no applications that could actually make use of that many cores.
Now there's Teams.
Yes. Well,
now all you got to do is run Chrome, and you can use all the memory. This is all. I think that this is a very important thing, and I think that what you're seeing here is the important aspect as well. That from an architecture standpoint, it's very much a roadmap, and it's very much a journey. And so we're starting with memory expansion within the box. The next step is going to be, in my opinion, the next step is going to be memory expansion outside the box. Then it's going to be memory pooling. Then eventually it's going to be fabrics and et cetera. And as Andy points out, it is difficult to make a network of buses or a bus network or something like that. And that's been a big challenge. Some of that work was already done. For example, there was a protocol called Gen Z that was really focused on building a fabric, a fabric interconnect for servers. All the Gen Z work is now being folded into CXL. So the Gen Z consortium has been absorbed, and all of the patents and everything is all in there. And they're going to be bringing that into CXL as well, because I think they realize that. Another one of the things that I like to see as a storage person, as Andy said, we've been trying to solve the fabric problem for a long, long time. Cache coherency is not a new thing in storage. And a lot of the people working on building CXL came from the storage space. And so that actually gives me a little bit of hope, because I realize that some of these people have actually experienced these challenges before and figured out how to solve some of these challenges in the past, or at least figured out what doesn't work over decades of hard learning.
Yeah, and it did. One of the key things I got out of this is, actually Gen Z is good for something.
Well, one of the problems with some of these earlier attempts at fabric and interconnect and composability was that they weren't adopted. And they basically, it was too much of a barrier to adoption. Even though people were on board, even though people were on the committee, they didn't actually implement it in their products. We saw that with some of the open standards for processor interconnects specifically, where some of the companies didn't adopt it. As Allyson points out, these not only are they being adopted, but they are PCI Express and CXL concepts are fundamental to the next generation architectures that we're seeing. So AMD, Intel, and ARM especially are 100% using this technology in ways that aren't visible and exposed. And Intel is even using many of the concepts of CXL in their UCIe chiplet approach. And similarly, we've had ARM come in and talk about how they're going to be using this with ARM CPU cores, and it's going to be just baked in. And so essentially, if you are worried about adoption, it seems like the next generation of AMD, Intel, and ARM chips are 100% going to use CXL, whether you want it or not. So that's a positive sign as well.
You mentioned that the next step is expanding outside the chassis. With that, has there been any thought around security to make sure that you're not opening it up to side channel attacks, bit flipping, stuff like that?
Yeah, in fact, that's been a huge deal. We've been talking to, and every company involved in switching and expansion outside the chassis, security is one of the things they brought up.
there's been a common reoccurring theme around real-time AES encryption on all of it, and specific processor instruction sets. What is it? VXT, or what is it? Basically, they're baking in instruction sets within the CPUs to try and lock out the ranges of memory externally in CXL the way they do at a kind of application layer, say within the OS.
Yeah. So like VTX is doing that for virtualization. And I think that's definitely going to be needed as well. Yeah. And also there's also a whole trusted computing base concept that's going to need to be brought here, because that's the other thing. Like, what happens if somebody plugs an untrusted device into the fabric? If it's got DMA access to servers in the fabric, that's challenging.
So a question about this, if you think about it, we already have protocols like this, hypercomputing, right, where we have clusters, we have InfiniBand, there's protocols, they're all in place. Is any of this being migrated over to CXL so it doesn't have to be reinvented? I mean, I'm not completely familiar with hypercomputing, but I know control your clusters, right? Protocols already exist to ensure cohesivity between memory and DMA, and security protocols are already in place. Do you have any insight how much plays into CXL with that?
Well, as far as HPC, it's definitely, a lot of the HPC companies are on board with this as well. And the same is true of open compute and hyperconvergence companies. In fact, a lot of the work with CXL is being done kind of hand in hand with OCP working groups. And as far as HPC goes, definitely a lot of the same people that developed those technologies are actually working on CXL now.
That would make sense. Yeah.
Which is pretty cool. Yeah.
Like NVIDIA are looking at CXL and NVLink. They still have their own proprietary version, but they're working on the shared version with CXL.
So I think that long term, from my perspective, with my background in storage, my first thought was not, now I can have a really big server. My thought was, oh my gosh, what is this going to do to storage arrays? And I think at the same time, when I thought of that, my next thought was, and what is this going to do to network devices? What is this going to mean for network switches and routers? What is it going to mean for firewalls? What is it going to mean for things that aren't servers? And I don't know, now that you have heard about this, think about your domain, think about your area of interest. How do you think this is going to affect your area? And I want to throw it to you because, as a networking person, how do you feel that this is going to affect your area if you have this kind of composability?
Well, sure. So it seems to me that like inside the data center, we have to abandon Ethernet, right? Because Ethernet is going to be super slow compared to this, right? I don't know what kind of speeds are we talking about. Okay, I see Craig going, so go ahead and tell me, what are the speeds we can expect here?
And full PCI Express speeds. 64 gig a second, a minute.
Per lane.
Per lane, yeah.
Per lane,
times how many lanes can we put on there? That's going to be it's going to be difficult for a traditional, 100, 400 gig network to actually compete with stuff like that inside the data center. Obviously, once you step outside, your racks in the data center, we can't. But no, this is, it's going to have to. We're going to have to look at that as a legitimate replacement, because if it does have the security built in, the encryption we were talking about, things like that, it's going to have a bunch of features that you'll need to add anyway. So perhaps that is a really valid replacement for inside the data center.
And specifically for top of rack. That's what they're talking about, is basically having a 400 gig CXL attached thing in each rack, and then not having Ethernet going to all the servers.
Because the question is the specification. How long can my PCI Express be, right?
That's
if
a good
it's,
question.
I get 400 gigs on 2 inches, right? That really doesn't help me.
Yeah, and nobody's saying that this is going to go 100 meters.
Mm-hmm.
Well, but it can go to the next rack, right?
I've seen multiple numbers. I think I've seen up to maybe 50 meters on our feature spec.
Oh.
But I think you're looking at something like 10 now for the products that we're seeing, and the advanced products that we saw, the CXL2 next gen stuff at OCP Summit. I think they were saying you could go to the next rack and maybe the one after that as well. It's not purely one rack.
Well, depending on how it's used, I could see Fortinet, Palo, and others using it to, you buy your firewall. You're not buying it with decrypt in mind right now, but you want to start doing SSL decrypt later. You plug in a or plug in a chassis that's got DPU cards in it to offload the decrypt to that.
Yeah.
Because decrypt is highly processor intensive.
Absolutely.
Even on the Fortinet side, they could even have trays of SPUs, NPUs, so you're allocating the security capability where it's needed within devices, in terms of throughput.
But for the Cisco, not just Cisco, you only have the backplane that uses PCI Express, right? Most likely. So the only benefit will be I can physically separate the switching unit from the control plane and the processing plane. But they're already proprietary solutions out there, so I don't know if there's really would be any benefit to that. But it's definitely interesting.
I think inside a Cisco chassis, for example, right? Maybe not, but
Yeah, but you wanna
but like,
separate it.
but if you build modules of compute, I'll say that's a terrible term, but there's really no need to even have a piece of network gear in there. It's all going to talk amongst itself as fast or faster. So, the network gear itself, like you're saying, it's pretty fast, and our limitations are the 2 inches at 40 gig. Right? It's not really
Or even making chassis stacks faster, because right now they're usually using stuff like 100 gig or 400 gig optics. With this, have the inter-chassis communications potentially as fast as within the chassis.
Yeah, exactly.
And also, I'd say silicon photonics has a part to play in here as well. And I think that starts getting exciting in terms of interconnect. We aren't hearing yet about using silicon photonics for CXL interconnect, but it's obviously something that they would be looking at with PCIe 6, I think.
Which hasn't even been specified yet.
But another great aspect here is latency. If we look at NVMe, Optane was 10 times faster. Memory is 10 times faster. We're talking we're talking orders of magnitude faster here in terms of latency than existing networking hardware. Obviously every hop we introduce is going to add latency, but it's nanoseconds, not milliseconds. And that's a big jump.
In the architectures, how many hops are we talking about, though, versus a traditional, like in the data center network, right? Because you could have 5 or 6 switch hops in a traditional data center network that also has latency, right? So is it going to be a similar type architecture for inter whatever communication?
On the existing kit, the companies are coming out with, or will be coming out with in CXL2, we're seeing that they're normally sharing memory between 4 hosts. That tended to be the example that we saw across the board. And then given that there were flip chip PGA solutions, they weren't 1U. It could have been 2U, 3, 4U devices. Obviously, it's early, but if you're looking at 4 hosts sharing a tray of RAM, that should only be 2 additional hops, 1 to the switch.
Yeah, it's like an edge core edge type fiber channel type architecture. Right?
Yeah.
Well, then the limitations of the 2 hops is, that's kind of, you miss that in the math, in the rounding of the math at that point.
I think, is it CXL3 though, Stephen or Allyson, where it can be multi-hop?
It can be, and the node count that it supports is much higher.
128, I think.
I think it scales even beyond that, Craig. I could be wrong, yeah. But I think the cluster sizes get much bigger.
But I will say that one of the things that we heard was that a lot of the things that we're looking forward to here in terms of, rack scale and fabrics and so on, that's going to even be beyond CXL3. Even though CXL3 introduces a lot of the things that are required to support that, I think that what we heard from a lot of the companies that are developing these switches and fabrics is that it's going to be beyond that when that stuff really comes to fruition. So like Craig said at the beginning, we're looking at like a 5-year roadmap here, not a 5-month roadmap to get to disaggregated compute and rack scale architecture. Yeah.
And I hate using the K word because it gets used so much. But if we look at Kubernetes, 5 years ago, not that many mid-size enterprises were using it, and now a lot of mid-size enterprises are using it. And we know, due to the financial implications, that the hyperscalers are absolutely going to adopt CXL 1.1 and most likely 2.0. Just on being able to jiggle memory about, it's half the cost of a server these days, and one of the most wasted financial resources within the service provider. So they will adopt it, but there's always this trickle down effect where new technology comes, big companies, smaller companies, smaller companies, smaller companies. It will trickle down.
And I'd say the jury is still out, back to the point about Cisco UCS, for example, or, a Dell server, an HPE server. I think the jury's still out where enterprise servers, how enterprise servers are going to use this technology and how that's going to be implemented in blades. To the point that it may not be, at least for the time being, implemented at all. Or they may just use it for memory expansion for the time being or so. I mean, we don't know yet how this is going to be felt in the enterprise data center in the near term. I think in the long term, we see some opportunities or optimism that it will lead to disaggregated rack scale architecture. But there again, you're kind of at the mercy of the system vendors as well, because how many of us are going to build our own system based on a technology? No, we're gonna wait until Dell or HPE or Lenovo or somebody offers it as part of their certified solution, and we'll see how they adopt this and what they like to do with it. So, yeah, that's kind of the long term. So, I guess final words here on CXL.
I'm putting a lot together and trying to figure it all out. Biggest thing for me is, how is this going to change the data center as a whole? How is this going to change the power? How is this going to change the heating of the data center? How is this going to change the aftermarket ability? It's like, you're putting a brand new stereo, a different stereo into a car. And so that can cause a whole host of new problems when it comes to data center, and somebody trying to overload something because they think that they can do that, and they just don't understand that those are all the specs. So this could be, I could see a lot of advantages to doing this, especially somebody that's on cutting edge that needs all that space to and option to do more. But also, it could be a big hindrance for any IT professional, especially if they just say, "Oh, let's go buy this product from China because it's 20% less than what we can get at an HPE or something like that."
Yeah, I just don't see that happening in the enterprise. Yeah.
Some people do. Some people do it.
Anybody else want to dive in here with a kind of closing thought?
Yeah, I'll dive in. So I think there's a great potential. My fear is the security aspect, and that in specification 1, it's not really there yet. Specification 2 is considering it. They're trying to figure out, and that gives you a bit taste of like bolted on security after the point, and that has not gone well for the IT industry in general. I think if they get over this, right, if they have the security figured out, then I think the next step is the hyperscalers who will really dive into it. They have the resources, not the smaller to medium businesses. They will not be touching this for a long time. So to your point, it's really readily available at a vendor like CDW, where I just want a CXL solution. Great potential, but also worried about the security aspect of it.
I'll second that. The security aspect of it and the true scalability of it is again, the other thing. It makes sense if you have one switch, if you have 2 hops total. If you try to go to 3, you run into all of the networking issues. You need to have some way of actually handling the multiplex, demultiplex issues associated with it. And I see this as in actual use, it will look an awful lot like a fiber channel network where you will have one layer of switches between the 2 devices.
Yeah, probably one interesting thing again is the applications are going to have to change. And that goes without saying. Just thinking about Kubernetes out of interest, I mean, I'd say you'd have to create a new, especially if we're talking about pooling memory. So instead of having just your nodes have a certain amount of memory, you'd have to create a new API object, pooled memory. But I think with technology like Kubernetes, that might be able to be implemented faster because Kubernetes comes out more often. They'd be able to put a beta in and whatever. So, maybe it wouldn't take too long.
But that's a good point, though, because, we need software abstractions. We need a way of describing it in software. I know that VMware and Microsoft and the Kubernetes community are working on that. We talked to them. And so, I definitely think that's coming. Yeah.